This video is our second WJEC past paper question on coordinate geometry for the C1 course. The question that was asked: we were given the points A and B with the coordinates 1, 2 and 5, 10. We were told that the midpoint of AB was called C. Firstly, we were asked to find the coordinates of the point C. Remember, that's the midpoint. We're also asked to find the gradient of the line AB. Next, we're told that a line L passes through the point C and is perpendicular to the line AB. We're asked to show that the line L has the equation given. And lastly, we're told the line L intersects the x-axis at a point called D. We're asked to find the coordinates of D and then to calculate the size of the angle CAD. The whole question was worth 12 marks. Remember, we told that C is the midpoint of AB and coordinates of A and B are both given. We're going to use the formula for the midpoint, which is the average of the x-coordinates, the average of the y-coordinates. Find the sum of the x-coordinates, divide by 2. Find the sum of the y-coordinates, divide by 2. So C, the midpoint, has the coordinates 3, 4. Next, the gradient of the line AB. Again, a standard formula that you should know by now: the difference in the y-coordinates divided by the difference in the x-coordinates. We're given points A and B, y, take away y, x, take away x. The gradient is 3. Next, we're told that another line called L is perpendicular to this line AB. So we call upon our knowledge of perpendicular lines. The gradient of the line L must be -1/3. Of course, that is because the product of the gradients of perpendicular lines is always -1. Most questions will either involve perpendicular lines or parallel lines. So look out for this feature in many questions. So now we know the gradient of this line L is -1/3, and this will be the m that we will use in the standard equation of a line. Remember that the line passes through the point C, which we've previously worked out to be 3, 4. So the x1, y1 in the standard equation of the line will be the 3, 4, and the m will be -1/3. So using y minus y1 equals mx minus x1, substitute in -1/3 for the m, and the x1 is 3, the y1 is 4, multiplying through by 3 and expanding the brackets on the left and the right hand side leaves us one final stage, which is to collect terms to equate to 0. This is the equation we were told to find, so we can QED our answer. Next, we see that the line L intersects the x-axis at a point D. Now, this is not a simultaneous equation question. It's a little bit easier than that, and this part was only worth 1 mark. Of course, we remember that on the x-axis, the y-coordinate will always be 0. All we have to do is take the equation that we've just found, 3y plus x minus 15 equals 0, and substitute y equals 0. So when y equals 0, we have 3 times 0 plus x minus 15 equals 0, giving us the fact that x must be 15 at the point D. Of course, the y-coordinate was 0, so D is the point with coordinates 15, 0. Now, to calculate the angle CAD, a diagram would be very useful. Of course, you don't have to draw a diagram, but this time it does help us to remember that we have got perpendicular lines involved. the question is not so bad when we remember our basic GCSE trigonometry. We're trying to find the angle CAD. And using our knowledge of coordinate geometry, we could very easily work out the lengths of any of these three lines. It means that we could use trigonometry with the choice of either using sine, cosine, or tan. Any of these will require two lengths to be calculated. So I've chosen to take a look at using the length of the line formula to calculate the length CD. That's the line which is opposite the angle to be found. I've used the length of the line formula to calculate the length of AC, and that's the adjacent to the angle to be found. Remembering our GCSE trigonometry, the tan of the angle is opposite over adjacent. We've got our root 160 divided by root 40 coming down to the root 4, which is 2. That's not the angle, of course. That's the tan of the angle. And if we remember a little bit of our GCSE maths, the tan of the angle is 2. And so we're going to call upon the use of a calculator. Now this tells us that this particular question was probably set before the C1 exam came into place. So using the calculator to do the inverse tan, or tan minus 1, of 2, we get an answer of 63.4 degrees.